25.
How'd you get that?
You said it was times?
Yeah. What did you multiply together?
Yeah.
No, what did you multiply?
The 2 5s, isn't that 2 5s?
No, that's not true. This is mass of the 5 kilogram mass, and this is the velocity of the 5 kilogram mass initially.
So it's 20.
So it's
20.
20.
Kilo,
It's the mass times the velocity.
kilograms per second.
So 5 kilograms times 4 meters per second. The math problem is 5 times 4. And now the units. What are the units?
Meters per second.
Yeah. There's no fancy one-word thing like we've dealt with before. It's not like it's a Newton. It's just, it's a kilogram times a meter per second. So I can write that as a kilogram meter per second. Now, if you don't want to feel like writing that, you got some alternatives. Alternative number 1 is I know that force times time is equal to the change in momentum, and if so whatever the units of momentum are has to also be the units of this. Well, what is the unit of force? Okay, and unit of time? So this is also 20 Newton seconds. That is equally valid. But let's say you don't feel like writing that much. You have one other alternative, and that's to make up your own unit. Please do not use a unit or a letter that is already being used. If your name is Nick and you want to honor yourself and use a capital N, no, don't. Because we're already using capital N. I will sometimes use a capital D for honoring Descartes, who actually did some work with momentum. The D I'm going to define as a kilogram meter per second. I have to have this written down, otherwise it is not valid because this is a unit I am making up. If you use a capital D on a test or quiz and don't define it, I will take off that. So if it is defined here, in 3 lines being by definition, this becomes 20 Descartes. Very quickly, what is the initial momentum of the 3 kilogram mass?
6 kilogram meters per second.
It is not.
No.
You forgot the fact that we were dealing with vectors.
Is it negative?
Yes.
Negative?
The fact that going in opposite directions, this, as soon as this was said to be 20, we established that to the right is positive.
Yeah.
So this will be P3 initial, will be 6. I'll do Descartes because I'm feeling lazy right now. Negative 6, sorry. What is the total momentum before the collision? The total momentum before the collision.
14.
Yep.
D.
Descartes.
You just add it. The total before, and usually if you're talking about a total, that's when they throw in the capital letters, although capital P and lowercase p look very similar. That's 14 Descartes. What is the total momentum after the collision?
Well, 14.
Yeah, that's the whole idea of conservation of momentum. Whatever my total is beforehand, that's my total afterwards. If I have 14 beforehand, I have 14 afterwards. And so 8 times my final velocity is equal to 14. So my final velocity is going to be 14 divided by 8 meters per second, or 1.75 meters per second. It is a positive answer, which means they will divide and move to the right. And on that note, I will see you on Thursday.
Wait.
What?
Why are we dividing it by 8?
Because I ultimately wanted to figure out what was the final velocity here.
What is the
The
rest?
final velocity. I know my final momentum is 14 units. And that's going to be equal to the mass times the velocity. My mass is 8. Because they stuck together.